Bhubaneswar. I'm a student over there. I'm from electronics background, instrumentation and electronics. So basically, I'm a hardware hacker. I do things using hardware. So basically, I'm working with Internet of Things, and I gave a talk at Eurocamp about wave control automation, and now I'm working on RFID technology. So I actually try to combine these two to make better systems, better secured systems. So let's get started. So what is RFID? RFID is tracking technology in which we track objects from a reader. Objects are tags, and we read it with readers. I mean, basically, we can track anything at any moment with a reader wirelessly. I mean, we don't have to have a contact of a reader of the reader with the tag. It's unlike memory chips that we use in mobile phones. We have to have a galvanic contact from the chip to the phone's battery. But in these tracking technologies, we don't need a wired connection. It's pretty wireless and mobile. There are two types of RFIDs. One is active, or we can say it is semi-passive, and the second one is passive. In passive tags, we don't have any power source with it, but in active tags, we have a power source. I may sound weird because we have learnt it in school, like physics behind electromagnetic induction. The electromagnetic induction is the basic of RFID operation, in which we connect the tags to the reader with the help of electromagnetic induction to generate a power within the tag. Because the tag basically the tags that we use don't have any power source of their own. But in active RFID tags, we have a power source. That's an advantage. So what RFID does? RFID actually gives physical objects a unique identity. I mean, a physical object can be anything: our heating element, our refrigerator, our fan, or something of that sort. It gives them identity. If I have an identity, I can communicate with others. That's the advantages. That's the advantage of RFID. I mean, they get a virtual identity through which they can communicate with each other. I'll talk about Internet of Things later. Through some protocols, they can communicate with each other. This is the working of RFID, the electromagnetic induction that I was talking about. Use cases of RFID as asset tracking, some of the locking systems, security checks. Even they used for cattle tracking, and it has been used in hospitals. And come to the EPC. EPC is a standard of RFID tag. It's a standard of RFID tag code. I mean, what we sent from the tag can be encoded in this EPC. The EPC is designed from the EPC Global and the manager owner. It's basically a 12-byte core, 12-byte number, or you can say 96 bits of data that can be sent from the tag to the reader. Most of us are aware of the fact what Internet of Things is. I mean, Internet of Things is connecting things to the internet from anywhere, at any time, from any network. We can connect ourselves or our things to the internet. Then RFID, we can store the RFID contents in a database, whichever we like. I mean, we have to store the data from the tag to the computer, so that for the next time when we use the tags, we can be authenticated. The tag can be authenticated. I mean, we can match the ID from the tag to the database. for security systems. These are the things that I have been using for IoT using Ruby. Basically, a event machine server that I've been using, and frameworks, basic framework that I've been using is Sinatra for the browser client, and for the machine client, I'm using event machine WebSocket client. WebSockets are pretty flexible. I mean, different from the traditional TCP or HTTP. The connection doesn't break. The WebSocket clients are pretty consistent in receiving or sending data. So I've been using event machine WebSockets for the IoT application. These are the IoT devices. The Raspberry Pi, many of us know that it is a credit card sized computer with the previous models were having 512 MB RAM and the new model has 1 GB of RAM. It's basically very good while we consider Internet of Things, because these are very cheap and very used to operate, very easy to operate, and these devices can run operating systems like Linux or BSDs or something like that sort. The networking in IoT, basically what I was using is I send data from my browser client to the server, and from the server, from the internal channel of the server, it can be sent to any of the connected devices which are authenticated. So I am sending a message from the browser client to the server, and the other clients which are being connected to the server can receive the same message from the server. And after that, we can use the hardware stuff like global purpose input and outputs from the Raspberry Pi to control the hardware, or control any system that we want to. This is the whole RFID and IoT architecture. I am an authenticated user. I can log in into my browser client. I can send any message to the server. The server receives the data. Then it creates a channel for communication among the devices that I have at my home or anywhere else. These are clients getting connected on my previous system. This is my terminal. This is blue on a white. Anybody having any problem with that can talk to me later. Security considerations. I've been using FreeBSD as operating system in my Raspberry Pi. So I love using the jails framework from the BSD. That is pretty good for the security. So the concept of jails is that we can have a server in a jail. If we have a server in a jail, it cannot be affected from outside. Like when we do some SSH or something of that sort, it creates bad things, like right. I mean, you can enter into it and can manipulate stuff. So jails are actually kind of the same system within that BSD. I mean, a new BSD within a BSD. You can have multiple IPs in each jail, and there is no extra RAM usage for the jails, and a complete web server can be deployed in a jail. So there is no getting out of it. I mean, if you are trying to SSH jail, you will end up with providing the root access for the parent BSD. If you don't have the root access for the parent BSD, you cannot enter into the jail. So these are some easy jail commands. the EasyZell tool is used to create and to manipulate jails pretty easily. Then, and these are some applications that we can use with RFID and IoT. The demo that I'm working on right now is FreeBSD, native installed FreeBSD in a Raspberry Pi, so that I can make a secured system for Internet of Things. These are my links. So I'm going to show a demo of it's a virtual machine. I'm using FreeBSD in the virtual machine. I'm trying to show, sorry. So it is getting connected to my DNS server, and I have configured it to start the jails environments each time I boot my system. So it is starting my jails that I have created before. So I'm entering into a jail. Now you can see that my host name is Nohaman, and I'm entering into a jail. This is my jails console, and I have my host name as Pogs, and the username is root. I'm root now. So I have a directory in here, atom, and I have a server in here. Now it is listening to 3000. Now it is getting connected. Messages are being received, and what I'm trying to show is it has a IP 192.168.43.201, and if I am exiting from here to the parent system fconfig, I have a number of IPs here. I mean, the parent BSD system has a number of IPs including the jails. Again to the jails console, I'm trying to SSH it from the outside. Now I know the host name, now I know the IP of the jail. So, sorry. And it is asking me for the password for no haman. I mean, it is asking me for the root access of the parent system. If I don't have the root access to the parent system, I cannot enter into the jail. So that's all. These are the links. A web controlled robot that I have created before, that is on GitHub. And my blog archive, you can have a look at the BSD installation and stuff using Raspberry Pi in here. Thanks.
Any questions? Yeah, here.
Hello. So, since you said you have been expertise into hardware hacking, so I had a use case where probably I would like to have your suggestion. So I have a full-fledged shopping cart readily available with me, written in Ruby on Rails, right? And on checkout, probably I have a tilt which needs to get open, right? I hope you understand that. So it's a cache drawer which needs to get open on just you say enter, right? How do you try to fit it, with respect to hardware communication? Because it's a device which could be connected to a USB.
Using RFID or what?
No, not RFID. It's a normal serial port communication. It has nothing to do with RFID. Since it's a hardware related, I thought of just putting it in front of you.
Okay.
Any more questions?
Can we talk later?
Sure.
Thank you.
So you can take it offline also. We have a lot of time for all the questions that you can ask for. Yeah, so you go ahead and shoot. Do we have any questions at the back? There's one here.
Why did you choose FreeBSD jails over Linux LXC containers? Both do somewhat similar things, right? So,
I didn't use Linux containers. I used BSD for the first time using a virtualization to create a secure system. I never used Linux containers, so I don't know about the difference.
Right. Any more questions? All right, that's it then. So thank you, Tworit. Please give a big round of applause for Tworit here.